All right, let's solve some Leetcode really quick. First one is delete nodes from linked list presented in array. It's very simple. So what we're gonna do? We're gonna you're given an array of integer nums. Okay, and head of a linked list returns the head of modified linked list, removing all nodes at least that has value existing nums. So we create set of nums. Okay, and so we assign some values, some value to head, while current next if we may delete the first. So I would create guardian node just in front of it. So let's say guard this node this node assign value. Let's say we need -1, and next we head, and then current we assign guard, while current next if current next value equal in our set of numbers, we are removing, meaning current next equal current next next. And then we assign current. Yeah, we assign current next to perform motion in a list next, and we return guard next. Guard, yeah. My typing skills could be better. Okay, so this is works, but not this. Why? Because 2 is here. Why 2 is here? If current next value, current is a guard with a head, and yeah, I think we are moving here. So here we have to do else. In normal way, if it's not, we're just moving forward here. We have to assign not current to current, not current next, but current. But we reassigned it here, right? So, for example, if we have this, and we point in here, guardian here. So guardian next, current next will be this, and because it's in here, current next will be pointing to 3. Yeah, I think this will work. So in current next setting, oh yeah. Okay, a number of substring with only one. Given a binary string, return the number of substring with all characters in one. Since the answer may be too large, return modulus. So how long is 10.5? It's not that big. Okay. So what we're gonna do? We're gonna substring who is character. So this is like a combination formula, right? So what we're gonna do, we're gonna element in string, we're gonna assign continuous and total, and if element equal 1, we're gonna assign total whatever we have in continuous, else we increase, we set continuous to 0, and we assign continuous, increasing continuous here, and we return total. Yep. One answer. Oh, but fine. Okay. Why is there 0 answer? Oh, I think it's over. How to do 10. Okay, I don't know how to do this in Python. Yes, this is kind of. I think there is a more elegant way to write it. Yeah, the same. Okay. 56. What is faster? Modeling on the way? Yeah, modeling on the way could be faster. Splitting and calculating. Okay, next one. Number of pair string with concatenation equal to target. Given an array digit string target returns a number of pair indexes such as the concatenation of them equal to target. So we have this, target is this, valid pairs are is like combination thing. Given a digit target is the number of pair indexes. How many pairs? So, yeah, one way to solve it, we go through every and concatenate it and see if it works. Right? First two, then we got second two, we have square complexity. Mm, what if we sort it? So square complexity is not that bad. It depends how many we have. It's in 100. Oh my god, it's in 100. It's like square complexity is fine. But I wonder what if we sort it? Like, can we sort this guy? So for example, two. Okay, so it's not. What if I sort them by length and optimize this in this way? For example, we have a result is 1, 2, 3. I can only add one, so I check only this. I don't have to check entire array. I check only this guy because it's 3 and this 4. Can I create some kind of sorted by length? Like, or create some kind of list and sort it? I mean, like, um, create, and which is um, x, okay, it could be z in z and length z. From z in nums. And we sort it. So for Z, yeah. So we have 1, and then we have 2, and we have 3. So how about we create hash set of lists, like map, which is default dictionary of lists, and for element in n, we so we have length and element. We add ml append element. Therefore, and we have 7. For 2, we have 77. For 3, we have 777. Okay, then but the only thing is that we have to add index to it as well. So we will know that 70, this 77 can only be marked with this 77. And okay, so we have index. For length 1, we have 7 as a 1. Now, how can we count? Okay, so we can enumerate for the element in map, and then we can create store as a set. So we can check in items. And then we can say if key value if so we have result target string, right? Calculate target. If target minus k in m, we say and m k then we have to enumerate through every element. It's kind of too complex, but yeah, let's go. What we're gonna do, we're gonna extract target for elements in matching. We can say if element, so we have a list containing value and index. So we can say if index not equal our index, it's too complex. Let's enumerate nums. So we have index value in nums, and we can calculate key as a length of value, and we search for match. If we have a match, then we verify that not equal index, and we add result to store index and value plus e0 equal target or other thing equal target. We add this combination to the store, which is and we adjust result +1. At the end, we return result. Right? We assign result to 0. Yeah, it has add. So this is correct, this is incorrect, and this is correct. Why is this incorrect? Wouldn't 1, 2, 3, 4. Yeah, I think it's let's print store. I can don't need this value. I can do as a result of store. This is unique values, right? See, we have 3 2 or 2 3 and 2 3. They're both and 0 1 and 1 0. So there is a problem here. So here we can go like this. If call target, we add um, and we go leaf and not store, then we add. And for this, we also, I think it should be vice versa. So index is a value, it goes first. I think I'm overcomplicating stuff. It is, I believe there is a better way to find this, because let's say and not, let's add always index value. It doesn't matter which way we have, right? We are not counting like all possible combinations here. And not index value in store, then if or we always add this to store. Yep. You can also add it. And kind of okay, but we need the same here. Missing. Yep. Oh, man, I wrote a lot of SQL today. Mm. It's only 41. Starts with, oh, okay, yeah, start with is much better. Yeah, I agree. Next one, minimum processing time. If a certain number of processors is having 4 cores, the number of tasks to be executed in 4 times whenever each task must be assigned to core. You're given a array processor time representing the time each processor become available. Representing how long task takes to complete. Returns the minimum time. Okay. So is this four? Is this always 8 for 2 processors? I think it's always. Oh yeah. Task length is always 4 multiplied by amount of processors. So we. Yeah, I think we need to sort both processor time and tasks. Yep. Uh, Task is sorted by task and processor is sorted by. So is it number of tasks executed? We don't have information if it's sorted, right? It looks like it's sorted, but yeah, I don't know. So we have easier task, and we will start to. So the idea is that we take a harder task and assign it to um, easier processor, the most available processor, right? In this case, and v multiplied by 4. So what we're gonna do, we have a reverse of task. Let's print it, right? Yeah, so we will add 8 to processor 8, which is 16. Then we add 7 to processor 8. Then we add 5 to processor 8. But basically, we need sum of first 4 plus processor time. So, so we need minimum. So let's assign time. Let's call it mean time, and a really large value. And what we're gonna do, we gonna for index in len of but we can iterate processors, right? For processors, let's call it procs. For processor in procs, what we're gonna do, we gonna um, add to it what we have some task mm, can we enumerate so we get also index of processor? We may use it to multiply by 4. So what we're gonna do, index plus 1 If I do like clever way, multiply it by 4 plus so basically it's 0, right? We add 0, we add 1, we add 2, we add 4 because we are always right. So we multiply by I multiplied by 4 plus plus 1 plus 2 plus 4. And then we need mean time. We say if mean time is more is less. No, it's more. So this more, we assign this guy here, and we return mean time. Yeah. This. So basically, if 0 will be 0, 1, 2, 3. If 1, it will be 4, 5, 6, 7. Should work. Out of range. Why it's out of range? Oh yeah, plus 3. Yeah, so you know what? Let's calculate this guy here. So we assigned time, total time. Expected 16. 8. Why it's always 8? Okay. So for first processor, let's print this guy. So we print index processor. Oh, because we have to add to current processor. We cannot just add it. We have to add processor plus or processor time. Let's call it processor time. Because we cannot start from 8, right? We cannot start from 0. We have to start from 8. Plus, plus, plus. And okay, here we go. Oh man. Come on. So we have 0 and we have 32. And we have 18. What? I think this is wrong. But how we got 32 again? So we 8 plus 8, 16, right? Then we add plus 7. 4, 5, 6, 7. Design add the indexes to the first processor. 4, 5. Oh, smart. So 0, okay. Let's see. And if we have a 0, 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7, we assign to 0, right? To the first processor available time 8. So we max. Oh, it's a 4 core. Yeah. It's a 4 parallel core, not. This is why we got it. Okay. Makes sense. Yeah, I should be reading this. It's like solving different problem. Yep. Pending task. Okay, so we sorted task, we sorted processor, and we get in backwards. A pending task, and then processor we add in tasks and everything else. It's pretty much the same. But question why my code is slower? Is it because of Max? Probably. Okay, next, letter permutation. Given a string S, you can transform every letter individually to lowercase or uppercase to create another string. Return all possible strings we could create. Return the output in any order. Okay. So this is lowercase. It's kind of backtracking problem, right? So um, so what we can do, we can enumerate in all indexes for strings of len of strings, and we can decide. We can create like bt function which accepts string, and basically there are two possible variants for every. I don't know if we need backtracking here. So we enumerate string, and no, we convert string to list. Let's call it list. Then we say for element in list or character in list. We say if character in alphanumeric, then we have a result. We add result, append normal list. Where I need backtracking here. So how backtracking should work? Backtracking will accept string and index, and then if len of the string is equal, we have result outside. If len of the string is equal L, we append to result, right? We add thing to result. And this will be list. But yeah, let's not worry about it. We append join. But then for e in length of string, starting from let's say index starting from I, we call pt of current string plus. But we have to find if this is in so we say if id in alpha, we add id, backtracking. And we to upper, I think, right? Upper, just upper. Else we just bt. And we return result. That will be fun. I'm not sure about this code, but let it run and see what happens. And here we call bt on empty string, empty list, and 0. But we cannot just call it as ID, right? We need to create small list of, or yeah, let's do this. Yeah. Oh, let's call it large as. Oh, this is because it's alpha. Alphanumeric. Check if alphanumeric is a num. Alpha num or is alpha. Is alpha. Okay. So is alpha then. Mm. And then so how are we gonna do this? We have to remove last one. Can we push? And then we pop. And then we push upper. And then we pop. Right? Kind of messy, but I think it is. Why it's still returning result append? Join whatever with that. Because it's never reaching what we need. Oh, oh my God, yeah. Index alpha range. Why it's only AB? Oh, it's an A1, B2. Yeah, it's correct. So length will be I can say if I equal L minus 1 and I say return, it may be I'm using some kind of, let's call it I1. If I1 is alpha, why is that? So we started from 0. Yes. Oh, cool. I don't know why. So let's say we have state. Because it's different. State is a state. So we state push, we state pop, we state push, we state pop, we state push, and we state pop, and we calling this a state to backtrack next, right? This is state as well. Here is correct. Yes, this is single letter naming is bad. Object has net attribute push. Okay, so as the object has append, yes. So we append. Okay. Wow, that's too much. Oh, because we. Oh, okay. So I understand why. Because we are adding and building like ABB all the time. Okay. I'm overcomplicating it. It shouldn't be this way. For every DT, I'm getting next to. It's like all possible combinations. Yeah? So A1, B1, 2. So we have A1, A1B, because we are printing all possible states, but we need to print results. Go. Okay, it's almost like an hour and I'm stuck with this backtracking. And yeah, it's fifth medium. It's kind of too much. Yeah, I'll land on that and see you next time. Bye.